Hello students, welcome back. Let's have one more exercise on Laplace transformation. We completed this problem. Let's go to the next problem here. This is the given ordinary differential equation, given linear ordinary differential equation with constant coefficient. And then let's take the Laplace transform for each term separately, and I'm going to need a special font for that. Okay. Second derivative. First derivative. The original function. And then finally, the right-hand side. And let's do some color coding as well. Second derivative. First derivative. And then the right-hand side. Okay, all right. What's the Laplace transform of the second derivative? S squared y minus s to the first power y of 0 minus s to the 0 power y prime of 0. That's it. How about the first derivative here? S to the first power y minus s to the 0 power y of 0. 2y is equal to, let's see, how about the Laplace transform of e to the negative t? By the way, this is red, this is blue, and then this one, well, let's check. E to the negative t power, alright, 1 over s minus a. A is negative 1, so we need 1 over s plus 1. And that's green. By the way, the input derivative formulas, they're not difficult to memorize. No, not these. They are here. Yeah, okay. S to the nth power, capital Y, n minus first power, n minus second power, they go down, 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 all the way over to 0th power. On the other hand, y of 0, y prime of 0, y double prime of 0, all the way over to n minus first power of 0, they just go up. So they're not too difficult to memorize, as a matter of fact. As for all these functions, well, you'll probably have to look those up. Exponential appears so many times, so I actually do remember. It's 1 over s minus a, I do remember, but other functions kind of hazy to me. Anyway, okay, all right. There you go, and we want to get the initial conditions done here. Y of 0 is equal to 1, so this is 1. That's equal to 1, so times 1, I don't have to do anything here. And then y prime of 0 is 3, so that's 3. Okay, over here, this is 1, so times 1, I don't need anything, and this is that. I guess I'm ready. Okay, all right. So s squared plus 3s plus 2 capital Y, and let's see, we have s, and then minus 3 and then another minus 3, so plus 6. I hope I'm doing this right. Let's see, minus s, minus 3, and then another minus 3. Okay, all right. S squared plus 3s plus 2 capital Y is equal to s plus 6 minus 1 over s plus 1. Did I get everything right? After flipping all those, okay, and then divide by this coefficient part. Looks like I'm gonna need some space in between. No, what I need is more than just space. What I need is bigger font. Okay, what is this? I can go to the textbook author's method and try to do this decomposition using the manual method. I'm not going to do that. A part, and I'll just copy and paste this part, and I'll ask computer algebra system to do that. And this is what I got. I got, let's see, negative 5 over s plus 2 plus 6 over s plus 1 minus 1 over s plus 1 total quantity squared. Looks like that's what I got. Let's compare that with Mathematicus result. Okay, all right. I got those. All right, waiting for Laplace inversion. Okay, let's do the color coding, and this is gonna be blue, red, and green, unrelated with those color coding. And then you can look up what function corresponds to 5 over s plus 2, or as a matter of fact 1 over s plus 2, because 5 is going to be a coefficient. 1 over s plus 2. Let's see, what is it? It's this form. 1 over s minus a corresponds to the exponential function. We have plus 2, so this should be negative, e to the negative second power. So that comes from the first term. Next, 6 times 1 over s plus 1. Again, the same thing, s plus 1. S minus a corresponds to e to the at power. This s plus 1, so it's going to be negative 1t. So e to the negative t. That's red. And then green. Now we have 1 over s plus 1 squared. Let's go over there. When do we have squared? Like this. Square and 1 factorial and then square. So that's when t is t to the first power, n equals to 1. So I can rewrite it as t times e to the negative t power, and that's green. And that's supposed to be the solution, right? If I did everything right, this should be the solution. Let's check. Clear all the variables here, and then y of t is defined as negative 5 e to the negative 2t power plus 6 times e to the negative t power minus t times e to the negative t power. Did I copy everything correctly? In the previous video, I didn't get the power correctly and I got something bad, and it took me some time to correct it. Is everything okay now? Okay, simplify, and I'm going to put this one in there. Second derivative plus 3y prime of t plus 2 y of t, and then subtract the right hand side, e to the negative t power. Oops. I should be getting 0, but I didn't get 0, which means something is wrong here. I hope I can find it quickly. Otherwise, I'll stop this recording and then look for it. Okay, I found it. It took me some time. Did you find it? Right here, I made a sign mistake. If I flip this one over to the other side, over here, what do I get? That equals to s plus 6 flipped over to the other side, so that positive. So this is plus. And then divide away this coefficient part to the other side. This will be plus, but I missed it. I have minus here. So that should change to plus. And all these are wrong now, so let's correct it. So this one should be plus. So apart this one, and we have new decomposition by partial fraction. So I have negative 3 over s plus 2, and then 4 over s plus 1, and plus 1 over s plus 1 squared. That's what I get. So if I go over and then get all those Laplacian or Laplace inversions done, this is the same except that coefficient is now 3. This is the same except the coefficient is 4. This one, we have to change this into plus. So change this to 3, change this to 4, change this to plus, and ask Mathematica to simplify this. Left hand side minus right hand side, left hand side minus right hand side. Am I going to get 0? I got it. So this is a solution of this ordinary differential equation. Now, I'm not completely done yet. I've yet to check the initial conditions. So let's see. Y of 0, what is it? Y prime of 0, what is it? Are they 1 and 3 respectively? Yes, they're 1 and 3 respectively. So I checked everything with Mathematica, and finally everything checks out.